Okay class, so it's last class we have started the topic probability, in which we had discussed the basic questions of a probability, and in last class I have also told you the concept of sample space and general questions and a general working formula to find the probability, right? Now in today's class we are going to start exercise 3A. It's your book 4 7th edition. Okay, it says a fair coin and a fair six-sided die are tossed and rolled respectively. Now if you talk about coin, so there are two possible outcomes, that is head and tail. And if you talk about a die, then there are six possible outcomes, and that is 1 2 3 4 5 6, right? The question says, using set notations, list the sample space of the experiment. Now it is quite possible that you got head on the coin and 1 on the die, right? Similarly, it's also possible that you got head but a 2, a head and a 3, a head and a 4, head and 5, head and 6, right? Likewise, you can get tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6, right? So these are all the sample space that was asked in the question. That is your answer. Simple. After that, moving on to question number 2, it says a box contains 7 pens, 3 of which are faulty. A pen is drawn from the box at random. Using set notations, list the sample space of this probability experiment and find the probability that the pen drawn is not faulty, right? Now a box contains a total of 7 pens. We have done a similar question in our last class, 3 of which are faulty. That means if we are talking about the pen that are not faulty, they are basically 4, right? Total pens 7, the faulty pens are 3, and the pens that are not faulty are 4. Using set notation, list the sample space. So your sample space: faulty pen 1, faulty pen 2, faulty pen 3, and non-faulty, I said non-faulty pen 1, non-faulty pen 2, non-faulty pen 3, and non-faulty pen 4. So there are 7 possible outcomes that you can get when doing this experiment. You need to find the probability that the pen drawn is not faulty. Now there are 4 chances that a pen drawn is not faulty, so it will be 4 divided by total number of pens are 7. So that is your answer of first part, the possibility of not faulty pen. Suppose that the first pen drawn is not faulty and it is not replaced in the box. Not replaced in the box, it means that you pick a chocolate and you ate it. So now it will reduce your sample space. A second pen is now drawn from the box. Using set notations, find the possibility that the second pen drawn is faulty. Now suppose that, let me explain with the example. Let's suppose I have some pens and I say the faulty pens are red. So 1 2 3 4 faulty pens, and the pens that are not faulty are black ones, right? So 3 normal working pens and 4 pens are faulty. In first part we have picked one of the faulty pen, right? So I have picked this red pen and I throw it away, right? So that means this pen now removed, and then I need to pick another pen. Now that is the second, you can say that second event, right? You pick a chocolate and you ate it, that's why it reduced the sample space. Now after that I need to pick a pen that is faulty, right? So how many faulty pens you have? You have 3 faulty pens, so it's 3 divided by, now the total number of possible outcomes are 6, not 7, because one pen we have already picked up. So it will be 3 divided by 6, that is equals to 1 divided by 2, and that is the possibility of the second pen that is faulty. So that is your answer, and we have done a similar example in our last class. I hope that you had remembered that example, right? So moving on to the next question. It's question number 3, and the question says, each letter of the word possibility is written on identical cards. One card is chosen at random. Using set notations, find the probability that the letter on the chosen card is S. Okay, so first thing, what we had done, we have made a card P O S S I B B I L I T Y, right? So let me write the word possibility, P O S S I B I L I T Y. That is the word possibility. One card is chosen at random. Now how many sample space we have? Counted 1 2 3 4 5 6 7 8 9 10 11, right? So the possible outcomes are 11, and we can say that the sample space is 11, and that is your the first one card is chosen using set notations. You can say that these are your possible outcomes. Letter on the chosen card is S. Now what is the possibility of S? So in those 11 cards, there are the possibility of S is 2. So I will say that for first part, possibility of S is 2 divided by 11. There are total 11 cards and 2 have S on them, right? So first part is 2 over 11. For our second part, it says a P or an I. Now first thing, you need to find the possibility of P. So P occurs only one time, right? So it will be 1 divided by 11 plus, if you talk about I, and I am going to shade the letter I, 1 2 3, right? So the possibility of I is 3 over 11. If you add them both, it's 4 divided by 11, and that is your answer, right? After that, in part 3, it says a vowel. Now how many vowels we have here? I am going to circle them with the red pen. O is a vowel, I is a vowel, I is a vowel, I is a vowel. So how many vowels we have? We have 4 vowels. So the possibility of a vowel is 4 divided by 11, right? Last part. Now there are 2 ways to attempt the last part. Consonant. The cards without the red marks, basically your consonants, and by definition consonant are those alphabets that are not vowels, right? So P, S, S, B, L, T, Y, they all are consonants. You can count them, so they will be 7 over 11. That is your consonants possibility. And second method is that you can say that probability of a vowel plus probability of not a vowel is equals to 1. Basically, not a vowel is a consonant, right? Not a vowel, basically a consonant. So possibility of not a vowel, or you can say consonant, is equals to 1 minus possibility of a vowel. it will be 1 minus possibility of a vowel is 4 divided by 11. When you take the LCM, it's 11. 11 minus 4, and that is equals to 7 upon 11. So the same concept that I had discussed in last class, probability of an event that it occurs plus probability of an event that it does not occur, that complement represents it does not occur, is equals to 1. So we can use this concept and we can use direct method as well. Both are correct. After that, moving on to question number 4. Okay, it says a box contains 3 cards bearing the numbers 1, 2 and 3. A second box, so I'm going to draw the diagram here, a sketch, roughly sketch. First box contains 3 cards bearing the numbers 1, 2 and 3. Second box contains 4 cards bearing the numbers 2, 3, 4 and 5. A card is chosen at random from each box. Display all the possible outcomes of the experiment using a possibility diagram. Okay, so the possible outcomes, either you can pick 1, either you can pick 2, either you can pick 3, and there are 2, 3, 4 and 5. Now how you are going the same information with the help of possibility diagram. Now first thing, what is possibility diagram? So let's say that is bag A and that is bag B. So the possible outcomes are, I can pick in bag A I can pick 1, in bag B I can pick 2, right? In bag A I can pick 1, in bag B I can pick 3. In bag A I can pick 1, in bag B I can pick 4. In bag A 1, in bag B 5, right? So I can make the whole table with the possible outcomes. And to cut down my effort and to save my time, I use the possibility diagram. So you have an idea what is possibility diagram. All those results will be observed more clearly and with more quickly with the help of possibility diagram. Now the question is how we draw the possibility diagram. Now in first bag we have 3 possible outcomes, so I will make 3 branches, 1, 2, 3, right? The possible outcomes are 1, 2 and 3. Now in bag B I have 4 possible outcomes, 2, 3, 4, 5. So I am going to continue with bag A options, right? So the green shows bag B and there are 4 possible outcomes, right? 3, 4. The numbers in bag B are 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. These are the numbers of bag B 2, 3, 4, 5. Now the cases are simple. From 1 it's 2, 1 it's 3, 1 it's 4, 1 it's 5. The same thing that I've written just before drawing the tree diagram. 1, 2 it's possible, yeah, yes. 1, 3 yes. 1, 4 yes, and 1, 5 yes, and then you will make with 2, 2, 2, 3, 2, 4, 2, 5. So this diagram basically cuts down our effort and saves our time. Now with this diagram you can find the result easily. In part B it says, with the help of the possibility diagram, calculate the possibility that the cards bear the same number. Now you can clearly observe from the figure that which 2 cards having the same number, this 2 and this 2, and this 3 and this 3, right? So basically how many possible outcomes are there? First thing, you need to find the sample space. Now I'm explaining first part here. Sample space are 4, 8 and 12. So there are total 12 possible outcomes, right? 12 possible outcomes, and the one we are looking for is 2 comma 2 first one, 3 comma 3 second one. So there are two outcomes which have the same number, so it's 2 divided by 12 and 1 divided by 6, right? Second part, the numbers on the card are different. Numbers on the cards are different, so there are number of possible outcomes. You will say that 1 comma 2 yes, 1 3 yes, 1 4 yes, 1 5 yes, 2 3 yes, 2 4 2 5 3 2 3 4 3 5. So there are number of cases. What I will do, I will use the shortcut for part 2. I will say that probability of same number plus probability of not same numbers, and now you all have know that they must be equals to 1. So basically I am looking for this one, right? Probability of not same numbers. So probability of not same numbers is equals to 1 minus probability of same numbers. It will be 1 minus the probability of same numbers we have find out in first part, that is 1 over 6. So taking LCM here, it's 6 minus 1, it will be 5 over 6. So that is your final answer of the numbers on the cards are different. If you do it by counting, I'm not going to do it because it will take time. If you do it by counting all the outcomes, you will get the same answer. So keep in mind that this concept is very helpful. It saves our lot of effort. Example of this question as well, right? Okay, for third part it says that the larger of the two numbers on the card is 3. Okay, so larger of the two numbers on the card, like 1 comma 2, no, I cannot take that, but 1 comma 3, yes, I can take that. 2 comma 3, yes, I can take that. And 3 comma 2, not 3 comma 3, not 3 comma 4, not 3 comma 5, because in 3 comma 5 the larger number is 5 and it says that the larger number must be 3. So the possible outcomes I have for this case is 1 comma 3, 2 comma 3, 3 comma 2. So I have 3 possible outcomes, right? So I will say 3 divided by total number of possible outcomes are 12 that we had already discussed. So it's 1 divided by 4. That is your final answer of the larger number of the two cards is 3, right? Now before jumping on to the next question, what I think it's necessary that you have a clear idea about the tree diagram. So in this question I have explained as well, but now I'm explaining you individually that what is tree diagram. Let's suppose that you have a coin, right? And we know that the sample space of one coin is head and tail. Now let's suppose you have 2 coins. Now the possible outcomes are either you get head on one coin and tail another coin, head on first coin and head on second coin, tail on first coin, head on second coin, tail on first coin and tail on second coin. So there are 4 possible outcomes when you have 2 coins, right? Similarly, if I ask you the question what to do, what is the sample space of 3 coins, so 90% students say that it will be 6, and I know that you have think the same, right? No, if you have 3 coins the result is not 6. Keep in mind the sample space of a coin is calculated by the formula 2 power n, where n is your number of coins. how many coin you have. If you have one coin, so two outcomes. If you have two coins, 2 power 2 is 4, then 4 possible outcomes. So if you have 3 coins, so 2 power cube is 8, right? So that means now you have 8 possible outcomes. And how? Let's suppose on first coin you have head, second head, but third coin you have tail. On first coin you have head, second tail, third head. On first coin you have tail, head, head, and you got all 3 heads. Similarly, if you have tail, so your sample spaces are like this, right? So that is a sample space when you have 3 coins. So keep in mind, when you have 3 coins, the sample space is 8, not 6. Mostly students, in fact most of the time 90 to 95% I got the same answer, that it is 6, but it's 8. Now how you represent this information on your tree diagram? So first thing, I am going to start with the first coin. So I am writing for you that it's first one. First coin, if I have only one coin, so I have 2 sample space, that is head or tail, that we have discussed here. If I add one more coin, so I am going to write second coin, right? So if I add one more coin, now there are 4 possible outcomes. And how? Now it will be after head, either you can get head or you can get tail. Similarly, if you got tail first, then it is quite possible that after tail you will got head or you will get tail, right? That is your second coin. And after the third coin, now it is quite possible that after the second head you will get either head or you will get either tail. Similarly, if you got tail, then it is possible then you will got head, tail, head, tail, head, and tail. Now the sample space, total number of possible outcomes. So you can count from here 1, 2, 3, 4, 5, 6, 7, 8, right? We had discussed the same 8 possible outcomes. So that information, that whole information is represented here in a short tree diagram. So that is why I say that tree diagram saves our time, cut down our effort, reduce the chances of mistake, right? Now continue with the same example. Now I am going to explain you the concept of at least and at most. Now if I say question, first part, what is the probability of getting at least 2 heads? What is the probability of getting at least 2 heads? And we are talking about 3 coins. 3 coins, right? So we are talking about 3 coins, and the question is what is the possibility of getting at least 2 heads? Now first you need to clarify the concept of at least. What do you mean by at least? If I say at least 3 oranges, so it means that it can be 4 oranges, 5 oranges, 6 oranges, but not 2 oranges. So at least means minimum value. Maximum could be anything, but the minimum should be this amount. Now if I say at least 2 heads, so in this scenario we can take this one, right? We have 2 heads, we have 2 heads, we have 2 heads, and we have 3 heads. But if I ask you, do you have at least 2 heads in this scenario? Obviously you will say yes. So at least 2 heads means it could be 2 or more than 2 are fine, but not less than 2. So the probability of getting at least 2 heads is not 3 upon 12, it's 4 divided by 12. And how come it is 4? 1, 2, 3, 4, right? This one, why? Because it says at least 2 head. At least means minimum 2, maximum can be any possible answers. We have 3 coins, so 3 possible outcomes. If we have 10 coins, that means 10 possible heads are, obviously it is possible. So you need to simplify it. It will be 1 divided by 3. So that is the concept of at least. I hope that there is a more clarification to your concepts. Now if I say, what is the possibility of getting, the question is same, at most 1 head. Now at most means what? If at least means lowest value, then at most means maximum one, max value. It means that I will consider the cases in which I have 1 head, but more than 1 head, no, I will reject it. Yes, less than 1 head, obviously I will take it. So let's see the sample space. 1 head, here is 1 head, right? 1 head 1, 1 head 2, 1 head 3. Can I take this one? Obviously I will take this one. It says at most 1 head. It means that the maximum value of head is 1. It can be less than 1 but not more than 1. The opposite of at least. Listen again. It can be 1 but not more than 1, or it can be less than 1. At most, maximum value is 1. If it is 0, it is fine, but not more than 1. That means the maximum value of 1 head, there are 1 case, 1 head present, 1 head present, 1 head present, no head present. Yes, at most it satisfies the condition at most. So there are 4 possible outcomes divided by 12. It's 1 divided by 3, and I don't know why I'm dividing by 12. There are 8 possible outcomes. There are 8 possible outcomes. So it's 4 divided by 8. So it's 1 divided by 2 for both cases. So that is an explanation that I think I should deliver it to you regarding the possibility diagram, because in your next question or upcoming questions you will use the possibility diagram a lot. That is why I think that it will be good if you have a clear idea regarding the possibility diagram. Secondly, the most important concept of the possibility is the replacement and without replacement. We have attempted some of the question regarding replacement and without replacement. Now I'm going to explain you with the example. Let's suppose first thing, the replacement one. I have some chocolates, green and blue, and green, blue, green, blue. So the possibility of green is 3 divided by 10 and the possibility of blue is 7 upon 10. Please listen it carefully. Trust me, it is one of the important concept of the chapter probability. I am going to draw the same figure in without replacement. Green, blue, green, blue, green, blue, and I take the possibilities same, 3 upon 10 and 7 upon 10. Now listen carefully. If it replacement, what is actually happening? You go into the room, there is a box. In a box there are some chocolates. The possibility of green is 3 upon 10, the possibility of blue is 7 upon 10. You pick a chocolate and without eating it you replace it, you place it back. So in replacement there is no effect on the possibility, they are same. No impact on the possibility in replacement, because what you are exactly doing, you are just pick a chocolate and keep it over there again. You are not doing anything, right? So that is a case of replacement. It does not affect the possibility or the sample space. they are same. But when you talk about the replacement one, now what is happening here? You pick a green chocolate and then you eat it. So obviously when you again going to pick the second chocolate, now there won't be 10 chocolates because you had already eaten one. So now the sample space is 9, 9, 9, 9. Now first thing for sure that in without replacement case you have a change in your sample space because you pick a chocolate and you ate it. In replacement you pick a chocolate and you keep it back. That is why there is no effect on the probability. Now you pick a chocolate, you eat it, and now you are going to pick another chocolate. Now let's suppose I pick a green chocolate first and I eat it. Do you think that if I pick the green chocolate again the possibility is same? Obviously no. First it was 3, now it is 2, right? But the effect of green chocolate, it won't affect the blue one. The blues are 7 here, so it will be 7 here. Similarly, if you pick the blue chocolate, it's 7 upon 10. After that, it won't be 7, it will be 6. But the effect of blue won't influence the green chocolate, so it will be 3. So that is a case of without replacement, right? So that are the two important cases in probability, and I hope that now you have an idea how we are solving the without replacement and what is the meaning of without replacement, right? In which there is a change in sample space and obviously the probability, right? So in my question we had done a similar example like this one, right? In this example we have plotted the possibility tree like the one I have shown below of the 3 coins, and then we have find out the possibilities from the tree diagram. It is very easy for us to use the tree diagram and find the solutions or find the answers, right? So I think that is enough for today's class. Inshallah in next class we are going to continue with the book questions. And what you need to do for revision, you can do probability from book 2 6th edition. Yes, probability you can find out the basic probability in book 2 6th edition. You will see number of questions that you can solve in order to clear your concepts just for practice. And inshallah next class we are going to continue with the same exercise, right? Till then you need to do practice and you need to take care of yourself. Inshallah next class we will continue. Till then, take care and Allah Hafiz.